Hello all, welcome back to Angular 19 tutorials. This video is a continuation of our previous tutorial where we learned how to create a template driven form in Angular, including setting initial values with setValue and patchValue methods and resetting the form using the reset and resetForm methods. Now we will take our existing template driven form to the next level by adding validations. Since we are building on the previous tutorial, I assume you are already familiar with the basics of template driven form. If not, I highly recommend watching the previous video before proceeding with this one. So let's start. We have created a simple user form. So this is our template file and this is our class file for the user information form. Now let's try to validate this form using built-in validators. So there are 5 built-in validators in template-driven forms. First is required. It ensures the form control has a value, and if the control is empty, the form will be invalid. Next is min length. It ensures the form control value meets the minimum length, and if the value is shorter than the specified length, then the form will be considered invalid. On the other hand, we have the max length validator. This validator ensures the form control value does not exceed the maximum length, and if the value is longer than the specified length, the form will be invalid. Next built-in validator is pattern. It ensures the form control value matches the specified pattern and the pattern is defined using a regular expression. If the value does not match the pattern, the form will be considered invalid. And the last validator is email. It ensures the form control value is a valid email address, and if the value is not a valid email address, the form will be invalid. So these built-in validators greatly simplify the process of form validation in template-driven forms. Now let's open Visual Studio Code Editor and see how it works in practice. But before we dive deeper into built-in validators, let's check the form status by printing the valid property like user_form.valid. Now open the browser and let me navigate to template driven form component, and here you can see as a result the valid property returns false, indicating that the form is invalid due to the required first name field not being filled. Here you can see we have marked required for this first name field. So ideally the form should not be submitted in an invalid state. However, let me open developer tool, and once I click on this submit button, I am getting the values of our user form. It means I can still submit the form even though it's invalid. And this nullifies the purpose of having validators if required fields can be bypassed. So in this scenario, what we need to do is disable this submit button if our form is not valid, so that the user cannot click on the submit button until they have filled in all the required fields, right? So let's do this now. And we know that the form group has valid and invalid properties. The valid property returns true if the form is valid, whereas the invalid property returns true if the form is invalid. So let's use this property to set the disabled attribute of the submit button. And to do this, we have to write disabled attribute property binding equals to, here we can either use not operator with the valid property like user_form.valid, or we can directly use the invalid property without not operator like this. Both approaches achieve the same result. Let me comment out this line number 33 and save the changes. Go back to browser, and as you can see here, the submit button is disabled. This is because the user form is invalid due to the required first name field being empty. Now keep an eye on the submit button. As soon as I fill in the required first name field, the submit button becomes active. Here you can see. And if I reset the first name field, the submit button is disabled again. And refilling the required value re-enables the submit button. So this confirms that our disable submit button functionality is working as expected. Now let's start working with built-in validators. And as discussed earlier, the first built-in validator is required validator. This validator returns true only if the form control has a non-empty value. So let's add this validator to first three fields. And to use this validator, simply add the required attribute to the form control, which refers to the form field value. So here we have already added a required attribute to the first name field. Similarly, we will add it to the next two fields for last name and email. Okay. And I'll comment out the set values and reset buttons for now, but I'll keep patch values button enabled because as we implemented earlier, clicking this button will populate the three fields like first name, last name, and email. So this allows me to bypass manual entries for these three required fields and I can easily test the form's validation. So now let's observe the submit button's behavior. Initially it's disabled, but as soon as all required fields are filled, the submit buttons becomes enabled. So let me click on this patch value button and as you can see, the submit button becomes enabled and this is the expected behavior for any form. So let's do this one more time. I'll refresh the page and this time manually enter the values. Here, let me fill first name and as you can see, filling in just a first name field doesn't enable the submit button because we have marked three fields as required and the submit button is enabled only after all three required fields are filled. So let me fill remaining two fields as well. And now that all three fields are filled, and here you can see the valid property becomes true and that is why the submit button is enabled. Okay, so this illustrates how the required validator works, ensuring that user provide essential information before submitting the form. Now let's move forward with the second validator, which is mean length. And the mean length validator specifies a minimum character requirement for a form controls value. And to use this, we simply add the mean length attribute to the input field and assign it a numeric value. For example, I'll assign 5. So this ensures that the input fields such as first name field must contain at least the specified number of characters. So in this case, 5 characters. If the changes and let's click the patch value button to populate the required fields. And next I'll update the first name field and notice the submit button. When I enter the name like Bob, which contains only 3 characters, the submit button remains disabled. Also, you can see this valid property returns false due to the mean length validator, which requires at least 5 characters in this field. But as soon as I enter 5 or more characters, the form becomes valid and the submit button is enabled. So the mean length validator verifies that the length of the input value is at least the specified minimum number of characters and blocking form submission until this requirement is satisfied. Now let's use the max length validator, which works exactly opposite to this mean length validator, which means that with the max length validator, the input value does not exceed a specified maximum number of characters as defined in the attributes value. So I will apply the max length validator to the second field, that is last name, and the syntax is similar to mean length. Simply add the max length attribute and assign it a numeric value. I'll assign same value 5. Now again let's populate the first three fields by clicking the patch value button. And in the second field, if I try to enter more than 5 fields like X, Y, Z or anything, the max length validator will prevent me from doing so. In the second field, I cannot enter more than 5 characters. So this demonstrates the key difference between mean length and max length validators. Mean length needs at least 5 characters, while max length allows only 5 characters or less. Now, let's understand the fourth type of validator, which is pattern. This pattern validator requires that the control value must match the regex pattern provided in the attribute. For example, in this second field, let me increase the max length to 15 and the pattern is up arrow inside square bracket small a to z and capital A to capital Z plus dollar symbol. So this pattern ensures that the only letters are allowed, even spaces are not allowed. So let's test this in browser. Let me click on batch value button to fill first three required fields. And in the second field, if I enter any text less than 15 character, the form is valid. However, if I enter or type numbers like 1, 2, 3, 4, or if I add a space or special character like hash, dollar, at the rate, etc., the form becomes invalid due to the pattern validator, as well as our submit button is also disabled. It means we can enter only letters like from A to Z. Okay. So this is how we can utilize pattern validator to add a specific pattern, thus restricting user inputs and preventing form submission. So we have seen required validator, mean length, max length, and pattern validator. Now, last validator is email validator. I'll apply this to email field. And this email validator checks that the entered value is valid email address and it is typically used for email fields. Let's first test the email field without the email validator. If I remove this at the rate from this email address, as you can see, I can submit the form even if I enter an email ID without the at the rate symbol because our form is still valid. But adding the email validator, let me save these changes. Email validator restricts form submission. Now, if I remove the at the rate symbol from an same email address, the submit button becomes disabled. If I try to enter the email address here, abc@gmail.com. So as you can see here, it only becomes enable when I enter a valid email format, such as any name at the rate and then gmail.com or any other correct format. It means this email validator ensures that user enter a valid and properly formatted email address, preventing incorrect or invalid email submissions. Okay. So in this way, Angular built-in form validators can be utilized. But as a developer, we are aware of the validators applied to each field. However, from the user's point of view, it's essential to display short or meaningful error messages that guide them in understanding and correcting their mistakes. So now let's understand how to add effective error messages. And as we know, Angular automatically creates a form control instance for each form field that has the ng model directive applied. And we have already accessed properties such as value, valid, invalid, touched, and more of the user form using the template reference variable. In the same way, we can access the same properties of the form control by creating a new local variable for each form control. So let's get access to the form control instance by assigning the ng model to a local variable. And the syntax is hash local variable name. For first name, I'll use fname variable equals to ng model. This is how we can create a local variable for this form control. And by doing this, the variable fname holds a reference to the first name form control. Let's access the properties of form control. Let me copy the first four properties from here. I'll paste this below the first name field. Let me comment out this line number 3. And let me update this user form with fname. I don't need this JSON. Let me delete this JSON from imports array as well. And now, when I enter a value in the first name field, you just observe how the properties change. Yeah. The value property returns the entered value. The valid property returns true. The invalid property returns false. And the touched property returns true. So with the help of local variable of this form control, we can access these properties: value, valid, invalid, and touched. And this indicates that we have successfully gained access to the first name field properties, allowing us to track its state in real time. Now, let's make use of these properties to display the respective error messages. For that, we need to write the if condition. And you can use either the *ng if directive by importing the common module in the imports array, or you can use built-in control flow syntax using @if block. Since I am working on an Angular 19 application, I'll use the @if block syntax. And for this, I don't need to import any module in the imports array. So for this form control, we have added two built-in validators, mean length and required. So I wish to render two different messages conditionally. So I'll write the if syntax with the condition fname question mark dot errors question mark dot required. And we need to wrap this required inside square bracket in single quotes. Okay, so this first name refers to the form control instance for the first name field. After that, I have added question mark dot errors for safely navigates to the errors property, avoiding null or undefined errors. And then I have written question mark dot required. This checks if the errors object has a required property. And if this condition is met, I'll display a short error message. So for this, I'll use small tag with class text danger to show the error message in red. And the error message is first name is required. Okay. So similarly, I'll add another condition for mean length. So here I'll replace this required with mean length, and the message for mean length is the minimum length of the first name should be 5. Okay, save the changes and let's test these messages in the browser. And on page load, the message first name is required is displayed. However, as soon as I start typing, the error message changes to the minimum length of the first name should be 5. And once I meet the minimum length requirement, no error message is displayed because the field becomes valid. So this indicates that on page load, the required validator is triggered, and once I start typing, the mean length validator is triggered. But we don't want the application to display errors when the form first loads. Instead, errors should only appear after the user interacts with the field. And that is where the dirty and touched property come into play. A form control is considered dirty when the user manually changes its value, whereas a form control is considered touched when the user clicks or away from it. So let's try these two properties as well. So before this first if condition, let me add one more if block with condition fname.dirty or fname.touched. And now I'll move these two if block inside this if block. Okay. Now let's retest the functionality. And this time, no error message is displayed on page load. But when I touch the first name and leave the field empty, the required validator is triggered with message first name is required. And when I enter less than 5 characters, the mean length validator is triggered with message the minimum length of the first name should be 5. And when I enter 5 or more than 5 characters, no error message is displayed because this time our field becomes valid. Okay, so similarly, let's add error messages for the remaining two fields. Now I'll comment out these properties. And for last name field, let's create a local template variable hash lname equals to ng model. After that, I'll copy the same if block structure from here and I'll paste it below this last name input field. Now I'll update the local variable with fname. And also make sure to update the error message to reference last name. This is for last name. And for this last name field, I'll add error message to the pattern validator. The error message for pattern validator is last name does not match the required pattern. Okay. So this is for second field, that is last name. Also, I'll add the similar error message to the third field, that is email. So here, let me create local variable with hash symbol email ID equals to ng model. And let me update this L name with email ID. One error message for required. Email address is required. And second error message for email validator. And the message for email validator is please enter a valid email address. Now save the changes and let's test the forms validation. Now when I focus on a field and then click away without entering any text, as you can see, the required validator is triggered and displaying the respective error message. And for the first name field, entering less than 5 characters triggers the min length validator and showing an respective error message. Next, the last name field has a pattern validator, and when I try to enter numbers or special characters, I receive the error message last name does not match the required pattern. It means the pattern validator is triggered. Okay. Similarly, email field has an email validator. If I enter an invalid email address, I get the error message, please enter a valid email address due to email validator is triggered. So let me type the proper email address, and with this, our form becomes valid, and now we can submit the form. Okay. So with this, we have learned how to display error messages using built-in validators in Angular forms. Now last, let's understand how to disable all the browser's built-in form validation. And we can disable the browser validation by adding the no validate attribute on the form element. Like in HTML, the no validate attribute is used to disable the browser's built-in form validation. So when this attribute is added to a form element, the browser will not perform any validation on the form fields, even if they have attributes like required, min length, max length, pattern, etc. So, if the no validation attribute is used to disable the browser's built-in form validation, then why would we want to do that? Actually, this attribute is useful in specific scenarios such as custom validation. When we want to perform custom validation on the form fields using JavaScript, we can use the no validate attribute to disable the browser's built-in validation. Second, no validate attribute useful for server-side validation. In some cases, we may prefer server-side validation over client-side validation. So by adding the no validate attribute, we can bypass the browser's built-in validation and rely exclusively on server-side validation. So this approach is particularly useful for complex validation rules or when integrating with existing server-side validation frameworks. And third scenario is progressive enhancement. If older browsers doesn't support HTML5 form validation and we are still using HTML5 validation attributes without no validate, it can prevent form submission. So in this case, adding the no validate attribute can help by disabling HTML5 validation and allowing the form to submit. So the disabling browser validations can be bad for users because they won't get instant feedback when they fill out a form incorrectly. So only use the no validate attribute when it's really necessary. Now, moving on from the practical implementation, and let's discuss the advantages of template driven forms. Template driven forms offer several advantages, including easy to use. Template driven forms require minimal setup and configuration, making them user friendly to work with. Second advantage is rapid prototyping. Template driven forms enable quick creation and testing of forms, accelerating the development process. Next advantage is simple validation. It provides straightforward validation using HTML5 attributes, simplifying error handling. Next, less code required. It minimizes the need for extensive coding, reducing development time and effort. Next advantage is easy data binding. Template driven forms simplify data binding, automatically connecting from controls to data models. And last advantage is fast development. Template driven forms streamline the development process, enabling developers to quickly bind and develop forms. So these advantages make template driven forms a popular choice for building simple to medium complexity form in Angular application. Now, on the other hand, template driven forms also have some drawbacks, including limited control, restricts ability to customize form behavior. Next, difficult debugging makes it hard to identify and fix form related issues. Next, limited reusability. Form components are not easily reusable across applications. Next, tight coupling. Form logic is tightly coupled with template, making changes difficult. Next disadvantage is not suitable for complex forms. Struggles to handle complex form logic and validation. And last disadvantage is limited unit testing capability. Makes it challenging to write unit tests for form related code. So these disadvantages highlight the limitations of template driven forms, particularly when dealing with complex forms or applications that require more control and flexibility. So the conclusion is that template driven forms are a convenient and easy to use way to handle user input and validate form data in Angular. However, they may not be suitable for complex forms that requires more control over form validation and submission. So for such complex form, reactive forms are a better choice, which we will explore in the next video. So stay tuned by subscribing to FED Learning for quick and easy learning. Thank you for watching. Bye bye.